Welcome back everybody. So in this video we are going to discuss on how to find the resultant force. Okay, make sure to watch my videos on resolving forces, link in the description below. Now let me brush you a little bit on what I mean by resolving forces, finding the resultant of a force. So when I speak of a resultant force, so a resultant force is that one force that if applied it gives the same effect, gives similar effect as the former forces. Okay, but let me break it down. So for instance, you might be having maybe say two forces acting on this object here. Let's say this is a point here. We have two forces, this force and this force, right? Let me call this force 2 and this force 1, right? Okay, now a resultant force is the force that if acted upon on this object here, it will give the same effect as these two forces give on this object here. See, so this one pushes it this direction, this force 2 pushes this body in that direction, right? So if you have good imagination, we know maybe this might move maybe in this net direction, right? Maybe in that direction here. Now if we replace these two forces by this single force, maybe instead of removing all these time wasting forces, we just apply only one force, which will give the same effect. We will move with only one force in this direction, which will give the similar effect as these two forces. So this force here is called the resultant force. It's the force that can replace two or more forces and still give the same effect on the body. Okay, yeah. So now here in this video we're going to find the resultant of given forces. Now we discussed about the formulas we're going to use. We're going to use the parallelogram rule, whereby we have these rules here. We have the parallelogram rule, and we have the triangular rule, right? Now most students confuse where to use parallelogram rule and where to use the triangular rule. Now you are in the right place. Stay till the end, you're gonna understand. Now let's try maybe one example, simple example. Okay, you have this body here, okay, and this is pushed in this direction and this is pushed in this direction. Okay, let's say the angle here is 87 degrees. Yeah, random angle, because it's almost 90, so that's why I put 87. And let's say again we have a body here, one force acting, one force going towards this direction, right? Yeah, this is okay. Yeah, let's say here it's 90 degrees. Not necessarily 90. I can shift, let's say, this body here. One force is acting in that direction and the other force is pulling it in this direction. The angle here is 77 degrees. Now look at those examples. This force is going that direction, this in that direction. Now I want you to try and look, where will we use parallelogram rule and where will we use the triangular rule. Okay, let's start with this one. We have this point here. We have these two forces acting here. which rule is it, parallelogram rule or the triangular rule? We will use the parallelogram rule in this case. Here we'll use the parallelogram rule. Wanna know why? Because if this force acts in this direction and this force acts in this direction, if you are good at imagination, you know the resultant will be somewhere in that net direction, right? So if the resultant goes in that direction, the only way to find its value is by parallelogram rule. We can't use triangular rule. We know how triangular rule works. The triangular rule works by completing the triangle. That means if the resultant could be in this direction, completing the triangle, then that could have been perfectly the triangular rule. So here we'll use the parallelogram rule, right? What about this scenario here? Exactly, we use the triangular rule because this net force of this one will be, you see this force is acting downwards, this one is pushing it this direction, so somehow it will move in that direction, right? It's being put downward, this one is putting it the other way, right? So this body will move like this. So if I take it, I lift this line up here, it will be like completing this triangle. Sorry, I wanted to draw a dotted line, but anyways, so this is the resultant force here, this is the resultant force, so here it's the triangular rule. So I like using these imagination stuffs because they always work and they reduce the burden and burnout of cramming stuffs, right? What about this one? We have one force going in that direction and this one going in that direction. Imagine this force here, this body here, one body is pulling you, pushing you, going towards this direction. This one is turning you, pulling you towards this direction. So the net force, that means at the end you'll somehow move in that direction, right? This one pulling you here, this one is pulling you down, so you'll be at the center, right? So it's just like this body and this body here going in that direction. So here we can use the triangular rule. We can use the triangular rule down here. So here it works down here. This is the resultant force, right? Yeah, very simple. But if you are a pro at these things, you can realize that you can use here, you can also use triangular rule, you can also use parallelogram rule, you can also use parallelogram rule, but let us not confuse that one. Let's just go with simple analysis like those ones. I have parallelogram rule, triangular rule, very simple. Now, okay, what is the triangular rule? Maybe you should be knowing what triangular rule is. Make sure to watch my video on triangular rule and parallelogram rule. Make sure to watch my video on parallelogram rule. Now that you have understood, now let's go to the real solving of various problems concerning finding the resultant force.